Let's now have a more detailed look on what's going on at the synapse. Over here you see the presynaptic neuron, down here the postsynaptic neuron, and between the synaptic cleft. Now, if the terms presynaptic and postsynaptic don't tell you anything, then I would highly recommend that you watch one of my introductory videos concerning the nervous system or the neuron. Because this video is based builds on it. So the nerve signal arrives here from the top. This is known as the action potential. That's the nerve signal, and therefore this is the presynaptic neuron, and that's the postsynaptic. Okay, I admit my handwriting is a little bit messy sometimes, but I'm writing fast. So, and now the question is, what happens? How can the neurotransmitter be released? Remember, acetylcholine or neurotransmitter is released, somehow goes across the synaptic cleft over here. And how does this happen? And what are the different steps which are involved? So, let's get started. Number one, action potential arrives at the end of the axon of the presynaptic neuron. That's what I've explained over here. So I'm going to do that. I'm going to write a number 1 over here. And actually the action potential in nerve signal does not travel here in the middle, but it travels along the membrane. Okay, but not important for understanding this. So it arrives at the end of the presynaptic neuron. And then the following happens. The neurotransmitter has to be released. But the neurotransmitter is found in vesicles. And these vesicles, remember, are little membrane structures. And these vesicles down here, they contain the neurotransmitter that has to be released. And important to understand, no, it's not important for standard level or high level, but if you're just wondering where do the vesicles come from, they're transported from the cell body, which can be found all the way at the top there. They're transported down, and the neurotransmitter can be found in these vesicles. And what do? They fuse with the presynaptic membrane. So what you have over here is this, the presynaptic membrane, which I didn't draw properly, and the vesicles, what they do is they fuse. So they're in here, okay? So I'm going to draw an arrow. That's what they do. They travel to the presynaptic membrane, they fuse together. And what happens to the neurotransmitter? Look, there's a little gap here. The neurotransmitter is released and diffuses out into the synaptic cleft. That's the one over here. That's the synaptic cleft. A cleft is a gap, okay? So that's my neurotransmitter, and so I'm writing number 2 over here. That's number 2, because, well, now the number 2 looks like a vesicle itself. That's not what I meant, okay? I'm just circling the number 2 here. It's not a vesicle. And, okay, it fuses, releasing the neurotransmitter into the synaptic cleft. The neurotransmitter diffuses across the synaptic cleft, and they bind to the receptors, so they travel down here. And that's maybe number 3 is the diffusion. Diffusion of the neurotransmitter. And where can the receptors be found? The receptors are little membrane proteins. And wow, I should actually also have drawn a membrane over here. That's the membrane of the bad drawing. Membrane of the postsynaptic neuron, and there are little receptors over here. I'm just gonna draw them a little like Y-shaped or whatever structures over here. These are proteins, which is basically which is sticking on the postsynaptic membrane, and the neurotransmitter binds against these receptors. Okay, so I'm going to draw a dot. I'm just going to show an arrow over here, an arrow over here. So they bind against it. So they fit together like a lock and a key. If you have not heard of this principle yet, it's called the lock and key principle, which can also be found in enzymes. In any case, they diffuse across and then they bind to these receptors. Do I have to label the receptors now? Okay, let's call it receptor. Okay, so these are the receptors for the neurotransmitter. And when they have done that, what happens? The receptors open up, allowing sodium to diffuse in, and this causes a depolarization of the postsynaptic membrane. Now, what's that? I'm going to draw one of these receptors over here on the side because I have a little bit more space, okay? But actually, yeah. So that's one of the same receptors over here. A neurotransmitter has bound over here. And what happens if sufficient receptors are activated by the neurotransmitter, then there is a little hole, a gap, a channel opening up, and sodium, Na+, which is a salt, is able to diffuse in because the receptor allows it to go in. And so it's like a gate which is able to open and close depending on whether you have a neurotransmitter binding to it or not. And it opens up, the sodium goes in, and this causes a depolarization. And so it changes the membrane potential from minus 70 millivolts to, I don't know, plus 30. I don't know if this is the threshold level. It must be less than 30 because it's below the threshold level. Forget about it. That's detailed. But in any case, what happens is it causes the inside to become slightly more positive because the positive ions, the positive sodium diffuses in. So that's basically what the neurotransmitters do, and this is called depolarization. And once it has depolarized, what happens is that all of the other sodium channels, so they're not receptors over here, but we find sodium channels, open up, and Na+ will go in, and Aa+ goes in, and it travels down all the way. It's like a wave, and that is called our action potential, or at least the first part of the action potential, because there is also potassium going out. I'm not going to explain now because that's a different video, but we're already anyway more beyond that what I wanted to explain, because what we have to do is after the sodium has gone in and the next action potential is passed on, we still have a lot of this acetylcholine or whatever neurotransmitter we're talking about. A lot of this neurotransmitter is still hanging around here in the synaptic cleft, and that's a problem because if you do not remove it, then the nerve cell, the postsynaptic nerve cell, is going to continue firing. It's going to continue making action potentials because it thinks that it has to do that, because it thinks that it receives a signal from the presynaptic neuron, but actually it's not. It's the neurotransmitters which are hanging around here, which are causing it, but actually we don't need them anymore. So what do we have to do? We have to break it down. So the neurotransmitter is broken down by an enzyme, for example, cholinesterase. And I just realized that I totally forgot about adding these numbers, so let's do this first. So number 3, the neurotransmitter diffuses across the synaptic cleft and binds to the receptors. That's basically number 3 happening over here. And then the receptors open, allowing sodium to diffuse in. It's depolarization, so that's number 4. That's happening over here. And then number 5, the action potential is passed on. Okay, but because it's like in a wave, like in a domino effect, if you want. The sodium channels over here open up, and the sodium's all stream in, and you have this wave, this new action potential traveling down the nerve cell. So that's number 5. And number 6, we got to remove all of these neurotransmitters again. And there are 2 ways of showing this. Well, I can actually make an X here, indicating that I'm removing it. But you can, yeah. That's what I'm doing over here. I'm just taking the eraser here and I'm removing it. So my eraser is now playing cholinesterase. That's the enzyme, okay? The enzyme removing, I removed a little too much. I also removed the membrane, but it doesn't matter. You understand what I mean. Okay, and so that is number 6. Number 6 is the neurotransmitter is broken down, and the acetylcholine specifically is broken down by an enzyme called cholinesterase. In case you're wondering why some of these words are yellow, in case you don't know, because these are important words. So that's it. That's it. Okay. So if they ask you how is one nerve signal passed on from one nerve cell to the next nerve cell, then that's basically the answer over here. And one way of studying this is simply studying only the drawing. Remember the drawing, and then you basically, if you know and if you understand what's going on here, you can essentially regenerate this here without having specifically studied the text. All you gotta do is you gotta understand the process. Yeah? So, and that's basically, yeah, that's it, okay? And for those of you who think it's really confusing, I'm gonna do the following. I'm gonna do this very quickly. Action potential arrives, okay? Vesicles with the neurotransmitters bind against, with the membrane, releasing the neurotransmitter, which diffuses across, binds against the receptor. Sodium goes in, a new action potential is passed on. So that's number 2. That is number 3. That is number 4. Number 5. And number 6 is the removal of the neurotransmitter. If you simply remember this sketch very quickly, and in an exam situation you make a proper drawing and you simply explain what's going on over here, you're probably on the safe side. Okay, so that was it.